Flame tests. We now add the extra triple analysis tests, starting with identifying metal ions. A flame test identifies some metal ions by the colour they turn aflame. You dip a clean wire loop into the sample and hold it in a blue Bunsen flame. Lithium ions give a crimson or red colour. Sodium ions give a yellow flame. Potassium ions give a lilac flame. Calcium ions give an orange-red flame, and copper ions give a green flame. In the exam, a limitation to remember: if a sample contains a mixture of ions, the colour of one, especially the strong yellow of sodium, can hide the colour of the others. This is why instrumental methods are often more reliable. Metal hydroxide tests. A second way to identify metal ions is to add sodium hydroxide solution and look for a coloured precipitate. That's an insoluble solid. Aluminium, calcium, and magnesium ions all give a white precipitate, but you can tell aluminium apart because its precipitate dissolves again sodium hydroxide, while calciums and magnesiums do not. The transition metals give colours. Copper 2 gives a blue precipitate, iron 2 gives a green precipitate, and iron 3 gives a brown precipitate. In the exam, for the 3 white precipitates, add excess sodium hydroxide to separate them. Only aluminium hydroxide redissolves. Learn the 3 coloured ones precisely: copper blue, iron 2 green, and iron 3 brown. Tests for negative ions, anions. You also need 3 tests for negative ions. For carbonate ions, add a dilute acid. If it fizzes and the gas produced turns lime water cloudy, carbonate is present, and the gas is carbon dioxide. For halide ions, chloride, bromide, and iodide, add dilute nitric acid followed by silver nitrate solution. Chloride gives a white precipitate, bromide gives a cream precipitate, and iodide gives a yellow precipitate. For sulfate ions, add dilute hydrochloric acid followed by barium chloride solution, and a white precipitate confirms sulfate is present. In the exam, don't forget the acid step before the main test: nitric acid before silver nitrate for halides, and hydrochloric acid before barium chloride for sulfates. The acid removes carbonate ions, which would otherwise give a false result. Required practical: identifying ions. In this required practical, you use the tests we've just covered to identify the ions in unknown salts. You carry out flame tests and sodium hydroxide tests to find the positive metal ions, cations, and you use the acid, silver nitrate, and barium chloride tests to find the negative ions, anions. By combining the results, you can name the full compound. For example, a green flame plus a white precipitate with barium chloride will point to copper sulfate. In the exam, work systematically. Identify the cation and the anion separately. Then put them together to name the salt. Always note the safety point that several of these reagents are irritants or harmful, so eye protection is very necessary. Instrumental methods and flame emission spectroscopy. Modern laboratories often use machines, instrumental methods, instead of chemical tests because they're more accurate. They're also more sensitive because they detect tiny amounts, and they're much faster. One example you must know is flame emission spectroscopy. This is used to identify metal ions in solution. The sample is put into a flame, and the light given off is passed into a spectroscope. This produces a line spectrum that's unique to each metal ion, a bit like a fingerprint. The position of the lines identifies the metal, and the intensity or brightness of the lines shows the concentration. In the exam, Give the 3 advantages of instrumental methods clearly. They're more accurate, more sensitive, and faster than the old chemical tests. Flame emission spectroscopy can also analyse mixtures of metal ions, which simple flame tests cannot. Every metal has its own barcode of light. The lines say which metal, the brightness says how much.